All right. You guys can see my screen, right?
Yep.
Yes.
We can.
All right. Nice. Today is January 27, Wednesday. This is the data protection, Kubernetes data protection working group meeting. Today we have a couple items in our agenda, but majorly focus on one presentation from Velora given by Nolan and Dave. The first agenda is that our white paper is in progress. I think many of you are either been assigned an item to work on. If any one of you are interested in contributing to this white paper, please feel free to join. This is a work in progress. The second agenda is that remember in the beginning of this working group, we start to discuss how do we understand backup vendors, how did they do backup in the Kubernetes context? And we planned to do a series of presentations from different backup vendors. I think we did one for Kasten that was given. And Shin and I discussed about this. And we figured out this is a good time as there are multiple efforts coming concurrently in this community to see whether those designs we are making, progress we're making fit into the picture of existing for existing backup vendors. Today, we are glad that Lauren and Dave is going to give an introduction to Velora. This is a open source tool which can back up Kubernetes clusters. And if anyone is interested to do this kind of practice, please reach out to me or Shin on that manner. And then lastly, we will do some open issues if we have time. And then with that, I will hand the presentation to Nolan. I think Dave has not joined yet. Nolan, it's all yours.
Okay, thank you very much. Share my screen here. All right, is that visible?
Yes.
Yeah, I can see.
Cool. All right. So my name is Nolan Brubaker. I am tech lead for the open source components of Valero. Dave Smith-Uchida is also here at VMware and leading up a lot of the things we're building on top of it. So I'm going to just hop in and talk about what Valero is. So we can start by thinking about what we need to protect within Kubernetes. Folks on this call are probably familiar, but just as a recap, you can protect the YAML for your stateless apps, which could be done in GitOps. You also want to protect any sort of state stored in a cloud service. So things like Amazon's RDS or any sort of database that's a cloud service. You also want to store the state or back up the state that's in your Kubernetes persistent volumes, because those are not actually in the API, the Kubernetes API server, and those are critical to getting your work back up and running. And then finally, there can be some state stored in the Kubernetes API server. Things like a persistent volume aren't necessarily stored inside of your GitOps repo. So you've got some resources inside of the Kubernetes API server that are actually representative of state. So what Valero is an open source tool to protect these kinds of storage. It has two components. First one is it backs up the Kubernetes resources to object storage. So this could be S3 compatible, Google Cloud, Azure. We have a pluggable interface for that. But those are the big three API types that we support for object storage. The other component is snapshotting or backing up persistent volumes, the volumes themselves on your provider. So a Velora backup is composed of backup of the Kubernetes resources that lives in object storage, and then snapshots or backups of persistent volumes, which may or may not be shipped up to object storage. We have support for running Kubernetes anywhere, and that could be on vSphere, it could be on AWS, Google Cloud, Azure. We do not use direct etcd access, so that also includes managed offerings. Here in VMware, it is part of the Tanzu umbrella, and we have integrations with Tanzu Mission Control, Dell EMC Power Protect, and Red Hat's OpenShift. I'm sure there's others that we're not fully aware of, but we've got like a presentation from Caverno yesterday on integration with their policy engine. So like I said, we can back up all of the cluster's Kubernetes resources, but we can also do selection on this. So we can back up based on namespaces or select backups based on label selectors. We also have support for getting the persistent volume data via Restic for file system level snapshots, or doing snapshots at the storage system level. We offer support for execution hooks for quiescing applications or other operations. So if you've got a database that you need to pause or file system that you need to pause, something like that, Valero has hooks to do that. We can operate our backups on a schedule. You can interact with it via our command line or by submitting CRDs, which is essentially what our command line does. And you can restore backups into a new cluster, migrate to a new namespace, or you can restore into an existing cluster. Say you deleted something by accident, you can bring that back in to the existing cluster. So I'm not going to go too in depth on this picture, but this is a kind of a rough outline of how Valero works. You have the Valero CLI or kubectl or your own API that submits CRDs or custom resources. Those get submitted here and then are processed by the Valero server, which will invoke plugins to manage the different object storage, persistent volume storage, and we also have plugins that act on specific Kubernetes kinds or API groups. Through CSI, we can also create backups, and with our Restic support, we use constructs called pod volume backups, where we backup pod persistent volumes via Restic. And with Restic, we send that data up to the object store. So inside of Valero, we capture the cube resources and we put them into a tar file that we store in object store. So we can modify objects on their way out with a backup item action plugin. Often we don't, and we save the modification for them on restore, but sometimes this is useful. During this process, we also make snapshots via plugins, and we store a reference to that snapshot ID in our object storage. So we have a list of all the snapshots in that backup. And finally, during this situation, or during this process, we have the execution hooks called and process any data that they need to. If someone is using Restic, their file system data is also transmitted to the object storage, and that information is recorded in the tar file. And we also have some additional backup metadata stored in the object store. So the backup it was associated with, logs, shorthand for everything that was created in it, like a manifest. So that is that side. On restore, we fetch this backup info from the object storage, and we restore the Kubernetes objects from the tar file. We have a customizable priority order for restoring. So this is our default that we have right now. We basically process all the resources in this order, one at a time, and then we get to everything else at the end in alphabetical order. And we submit things in this order in order to make sure we can kind of stitch things back together on restore. So I mentioned we have Restic. This is kind of like an escape hatch if your storage system either doesn't have a Valero volume snapshot plugin or doesn't support CSI snapshots through the Kubernetes API. Restic is storage system agnostic. It works at the file system level, but it is not a snapshot, and the application either has to be quiesced or frozen for consistency. And it does take longer because it's on the file system running in essentially the same node as the worker pod. The volume snapshot plugins are very similar to what CSI snapshot drivers are now. These existed before CSI was kind of standardized, but they will interface directly with the storage system to take snapshots. And some of those plugins will ship those snapshots off of the node, such as the vSphere plugin. And like it says, these are usually block oriented, so they don't have to operate at the file system level. We can support cross-cloud migration with Restic. Since that's at the file system level, we're not dependent on a particular block API or having to do any kind of format translations. So we can send all the data into object storage, and then as long as both clouds can reach the same object store bucket, then a target cluster can pull down the Restic data and restore. So you can use this to move between two clouds. So for the future, we're looking to work with additional backup partners and kind of bring people in so that we have a broader understanding of what people want from us, and also to make components of Valero more systematized so that you don't have to install all of Valero to get some of your functionality. We want to present an engine to users that they can plug into. We're also interested in doing application integration so that Valero can snapshot applications. Right now, Valero works very much at the namespace and label level and doesn't have a whole lot of intelligence around what an application is. Things like Helm chart definitions, the app CRD, this kind of stuff would be really useful to read and build a graph of the objects that are being backed up. And with that, I'm going to open it up for questions. So yeah.
Thanks, Nolan. Any questions?
Yeah, this is Rob Esker. A couple quick questions. So I noticed, just kind of looking through, and I've watched Valero, I guess, going all the way back to its ARC days. I don't see a lot about sort of governance. Obviously, it's under Apache 2, and I see that you guys use contributor covenant for guidance on contributor sort of conduct. But I'm curious if you could speak to governance, and why is this not a what is your view with this vis-a-vis, like, for example, CNCF Sandbox? And I guess depending upon how you sort of respond to that, I had some questions about further backup partner integrations and what that would look like.
Yeah, so you're right. It's not been moved into the CNCF. Part of that is we're trying to be as open as we can while controlling it for full transparency. We do want to get good integration with vSphere. That being said, we're not trying to lock out support for any other projects. Right now, we don't really have any plans for donating to CNCF Sandbox. However, we do have this governance file, and we'd certainly be open to having those discussions.
Yeah, and I think we're really interested in having partners work with us, use Valero, contribute to Valero. We want to be really open about, you know, how we can merge, you know, work together and integrate. And vSphere is a factor, but it's not the factor. And we pretty much figured out how to, you know, it's a clear goal that Valero is not going to be a vSphere product, and it's not going to be a VMware only product, but it is integrated with a bunch of VMware products.
Yeah, thank you. I'll have a look at this.
I work with these folks. It's also integrated, to be clear, with some of our competitors' products, and we embrace the opportunity for a larger community with everyone. So,
Yeah, we've worked with Red Hat on improvements to Valero that feed into OpenShift solutions. We have done some partnering with Microsoft in the past. So, and it's not meant to try to lock people out, but yeah, it is still not on the timeline to look into CNCF. But we definitely welcome further contributors and input.
Yeah, I think one of the other things too is we've had people embedding it in different ways. So like OpenShift, for example, uses it as the backup component. So it has the schedule and all that stuff is used there. Power Protect is embedding it more as an internal component, more as infrastructure. So we're looking at breaking out these layers so that we actually break out an infrastructure layer separate from the product layer. And then we can really talk about how that infrastructure layer moves into things like CNCF.
I got a couple questions. The first one, Nolan, you mentioned the execution hook.
Mhm.
Is that a global level thing because you don't have an application concept at this moment, I guess?
So that is something we tie to the workload pod. So we have a variety of different methods of inserting it to a workload pod, and then we essentially call scripts that live in the workload pod. So it requires doing some annotations on your workload pods, or I'm trying to remember exactly how we execute at the top level, but we don't have anything that is like a backup wide execution hook. So it's on a per workload pod basis. For example, if you have a MySQL pod, you're going to want to run the hook in that pod.
Sounds good. Another quick question will be, the CSI plugin, right now, the Velora calls into CSI Snapshot APIs directly, not interact with the worm snapshot controllers, right? Not creating worm snapshot resources. Is my understanding right?
Oh, yeah. So the CSI plugin actually does use those volume snapshot CRs. So it'll make a volume snapshot and then basically include that in the Valero backup. The volume snapshot plugins, these kind of, for lack of a better word, legacy ones that we started with, those call directly into the APIs. So the AWS volume snapshot plugin calls EBS APIs, but if you were to run AWS with the CSI plugin, then it would instead submit a volume snapshot CR, wait for that to be ready, and insert that into the backup.
Okay, so by default, which one is the current status?
Right now, the status quo is using our volume snapshot plugin API. We would like to move to the CSI model, but it's not as widely supported yet. Over time, I think we're going to see our volume snapshot plugins get deprecated in favor of CSI. We'd really like to go that way. But right now, partly for getting the largest number of Kubernetes versions we can as a backup product, we're not doing that. And there's more work to be done on our side to make sure the CSI plugin works well. It's currently
there's no default, right? I think the question is there a default plugin? You have to specify, right?
There's no defaults included. It really depends on where you're running. But in terms of what I would call a default is our volume snapshot or plugin interface. But when you're installing Valero, you do have to install the plugins for your cloud. We don't install anything by default right now. Ideally, we get the CSI plugin either moved into Valero core, or we reorient things so that we're just using CSI.
Got it. And last question, sorry, I have a lot. All related to the ongoing efforts in this community will be Restic. When you do a Rustic backup, first of all, if I understand you correctly, right now it only works for file systems, right? That's one, and it scans the files.
Yep.
Prior to that, you mentioned there is a pod running locally on that node where the volume is attached to, right?
Yep.
How does that work with does it require the volume to be attached amount to your pod? If it is not a single writer, then you need to unamount from the workload pod and amount to your pod. Is that how it works?
Yeah. So the Rustic support goes through the volume directory on the node. We install it as a daemon set, and we look at what volumes are mounted to the pod, and then use that data path to get at the volume. So you're asking about rewrite many volumes?
Right.
Yeah. That support seems to be hit and miss depending on implementation. So we can back up certain NFS implementations by mounting through this data path, but there are some we've seen that we do not get all the time, that there can be errors. So we don't unmount the pod. We never unmount a volume, is probably a shorter way to answer your question. Longer term, we'd like to see the Restic integration be pluggable as well. So you could swap in. I know there's folks using Copia for this kind of thing, or there's another project called Borg, not the Google Borg. But longer term, we'd like to make the file system level integration pluggable, and then use it in conjunction with snapshots. So you take a snapshot and do the file system level backup of the snapshot, so you're not having to mess with freezing stuff and all of that.
Right. The interesting thing is that for local SSDs at this moment, it doesn't support snapshot at all, because it's it's just literally locally attached SSDs to that specific node.
Is that for GCP?
Not only for GCP, but also for many other solutions as well in Kubernetes in general.
Gotcha.
Well, that's an area where we could look at, for example, getting some file system snapshotting in there. Like if you're running ZFS as the file system on the node, then you could take a ZFS snapshot of the local storage.
Right. That's it depends on the infrastructure you're running upon. Yes.
Yep.
Yeah, and the Rustic backup is a change based, right? Because you only search for changes.
Yes. It'll be incremental at the file system level, but it still has to do scans, and it still has to do that diff and all of that. So it is slower. And our snapshot support is not directly incremental. We are able to use like Azure's API to request incremental snapshots, but that's not consistent across all the providers.
Got it. So how does this? Do you guys have plan to extend Velora to have management plan? How does the end user uses Velora backups for restoration, and how do they manage the deletion of this? Because it's under the hood, it's all managed. It seems to be the user will need to understand quite a bit at this moment, but I'm curious whether you have plans on that.
Yeah, so we'd like to, so one issue we have right now is because we back up through the Kubernetes API server, even if we back up at a namespace level, the expectation is that we get persistent volumes, which are cluster level resources. So you can't back those up or restore them if you're not a cluster admin. So like user self-serve is not really there yet. And for backup deletion, when a backup either hits its expiry date or a user issues Valero backup delete, Valero will go in, and the volume snapshot plugins have a deletion API with our CSI snapshots. We modify some things to go from like retain to delete. And then once that stuff's cleared up, we delete the stuff in object storage.
Got it. That's all I have. I have a lot to think.
Yeah, no problem.
Anyone from the community has any questions?
Hey, can you move? I have one quick question, I think. Just move to slide 7, the one above. So this page about the restore sequence, the priority order. So I thought CRDs are not restored by Velora. I thought user has to deploy the CRDs. Velora restore the CRs, but not CRDs, right? Is that right?
So Valero will install its own CRDs on install. So like Valero, when you install it, brings its own CRDs. But Valero does grab the cluster level CRDs. We have logic that says if I see a custom resource, I will go grab the definition and put it in the tarball.
Okay. Is that by default will not be restored or something? I thought there was something there saying you will have to include it for the CRDs to be deployed.
Yeah. So we had some bugs in 1.3 and 1.4 versions where they didn't execute in this order reliably. So something that would happen would be that your custom resource definition would be submitted to the API server, but by the time the restore hit the custom resource, the API server wasn't ready to make new CRs for that CRD. So we had a race condition that should now be fixed, that we properly process the discovery API. So there were some bugs around this previously, but by default, we should grab the CRDs and on restore, put the CRD in first, and then process the CRs.
Okay. Thanks.
Yep.
I have a question about the use case. So here we talked about backup, and also we mentioned using ZFS, for example, to snapshot local SSD type volumes. But those ZFS snapshots are local to the machine where these SSDs are. They don't get pushed to any object store. So my question is really about what use cases is Valero trying to cover as far as backup, application migration from one cloud to another. For example, like looking at this chart here, like we have storage classes. Like are we looking? I assume like storage classes would change from one hyperscaler to another. Are application migration in scope for Valero? Like what use cases are you trying to cover?
That's a great question. So originally Valero was largely based around these hyperscaler snapshot constructs, and those are often available throughout the whole hyperscaler infrastructure. You might have to do some manual migration of the snapshot, but to use Amazon as an example, EBS snapshots are stored in their own S3 infrastructure. So right now, Valero is, a lot of Valero's common use cases are within the same availability zone or similar construct, and moving from one cluster to another in that availability zone, or doing disaster recovery in that same one. We do backup storage classes, and with Restic and our restore plugins, we can modify the storage class on restore to a new cloud. But admittedly, that is a kind of a not as common of a case. We'd also like to see get to some point where we can duplicate our snapshots across AZs or across clouds, but it's not there today.
Yeah, so in terms of directions, so the current, so as Nolan said, the original model was like AWS. So you take an EBS snapshot, you're good, right? That goes into S3, and there's all kinds of magic behind it to keep it durable for you. However, you're stuck at AWS. So being able to extract the data from your EBS snapshots and maybe just ship it to another cloud just for durability is something that's there. But once you get data extraction, you pretty much have migration. So that's on the roadmap. And there's stuff that's coming out of what we did in the vSphere plugin, because the vSphere storage is a on-prem local snapshot setup. And so we built in stuff there to move data into S3. We're looking to move that up into Valero in the longer term architecture. Then there's the issue of like filtering and modifying resources. And we do have the ability already to, put plugins in here to filter and change things. There's the cross-cloud aspect of it. There's also even just like Kubernetes versioning upgrades. So you have an archive, you have like I don't know what we're at, like 119, and you're on 1.25. And when we do a restore, do we need to modify things to fit in there? And so we're working on filtering mechanisms in there as well, filtering and modification mechanisms.
Thank you. Is this filtering mechanism part of the open source solution, or is it like proprietary?
It will be open source. All the stuff we're doing here in Valero is going to be open source.
Okay, thank you.
I think some time ago, is it Raphael who gave a presentation on that, right? So if you have your source and target have different Kubernetes versions, and how to do that, how to support that, right? Is that?
Yep.
Did he do that? He did that here? Yeah, and so he's working with Valero to build that into Valero.
Okay.
Yeah.
In fact, there's even a PR outstanding at this point.
Yeah, there's a PR for handling it on the restore side. We have the foundation for it in the backup. We have the data we need, but we've got another team, not directly on the Valero team, but another team within VMware that is contributing to the open source effort to do that negotiation on restore. I see a question in the chat from Stephen Manley about how we approach, or how we want to approach app support. The question is the priority Helm integration, or a push for a more Kate's app definition, or something else? We have issues open for doing Helm integration and doing Helm as an entry point. Admittedly, that has been pushed down the priority map, our priority list, to get some other building blocks done. I don't think we've got this fully decided yet. I think Helm is great for meeting people where they are today. I personally would love to see more of a Kate's app definition, but Dave and I have also talked about using stuff like Istio definitions or choose your service mesh definitions. So I don't think we have a clear answer on that yet. Do you have more input there, Dave?
I have an architecture in mind. So the architecture that we're working with is in the Astrolabe project, and that is to start having what we call protected entities, which could be pretty much anything. So the idea being there that we start to expose snapshot and disaster recovery APIs for different types of objects. So one way you might do this, I have a prototype that I'll demo in a few weeks, is say you have like an operator. So for example, like the Postgres operator. Ideally, in my world, the Postgres operator should expose an API that says snapshot your database or snapshot your object really. And Valero or another backup app comes along and says, hey, would you snapshot yourself? And the operator goes out and does whatever it does to snapshot that thing. And then comes back and says, yeah, I got a snapshot. Here's a snapshot ID. And then later on, we can come in and we can say, hey, we need the data from you. Would you give me the data in your format? And we want to extract that and copy it somewhere. So that's kind of the big model. And then you can see things like, for example, we can build a protected entity that sits on top of, say, a Helm chart. And we can say, well, this application doesn't have, for example, an operator for it, but it's defined by a Helm chart. So we're going to have the Helm chart protected entity manager expose out a snapshot API for Helm chart X. And inside that, the Helm chart protected entity might go and say, okay, here's a Helm chart. That means that, I'm going to walk across it, pull these things together, snapshot these PVs, and I'm done. Or the same might be true for like the Kubernetes app definition. What we're trying to stay away from is building in one definition of application into Valero, because what we're seeing here right now, so like you've got Helm chart definition, you've got Kubernetes app definition. Okay, well, you've got two already, and you're going to come up with N, so we're not going to push everybody into defining their applications in terms of the Kubernetes app definition. I don't think that's going to happen. And we also need to be able to handle things that are external to Kubernetes. So that's kind of a long-winded way to say yes, and kind of externalize it and start looking at things as objects is my view.
But Dave, that's great. Great explanation. I have a quick question regarding what was the exact name of the project where you're thinking about this? You mentioned something which I missed.
This is Astrolabe. Let me put it in the chat. The documentation, I need to get back to the documentation and fix it up. But it's sitting there in the GitHub repository next to Valero, and we actually used it. We did a lot of the vSphere plugin is built on a lot of this, so we got some miles on the APIs and the concepts.
Yeah, so this is good. I mean, so what you're trying to say that the Kubernetes app definition is not, it's like there are many incarnations of that, and maybe stay away from that and come up with a slightly more abstract concept called protected entity, and you can kind of have that definition wrapped around a Helm chart or an operator, but which expose a bunch of hooks or actions that they can take, which is an interesting way to look at it, actually.
Yeah, because so I've been working on this for a couple, 3 years now, and one of the things, and I came out of the vSphere side where my goal was to get backup vendors to support new vSphere objects, because we keep on coming up with new stuff. And what would happen is the backup vendors, they would look at our new stuff and they go, well, where's the money? Do you have enough customers for this? And we go, well, we don't have customers because they won't install it until they can back it up. And they go, okay, well, call me when you got some customers, because there's no money. And so what I thought we should do is start flipping the model where there's a standard API that we as data protection people can use, and that instead of us trying to get data protection vendors to chase us and data protection vendors going around and chasing things, that we meet in the middle and we say, okay, there's an API. If we provide you with this API, you should be able to back it up, and vice versa. They can say, okay, did you give me an API so I can back it up? No, okay, well, when you got that, we'll talk, right? Mm-hmm. So that's kind of the big picture goal.
Yeah, the only issue I encountered this is with, it is great when you give the Postgres example and it's easy to explain, but as soon as it's Kafka, it's, people get, okay, what do you do with that? So
that's Kafka's problem.
Exactly.
No, seriously. I mean, that's the kind of thing.
Kafka, yeah, maybe nothing.
So, yeah. That's right. And that's where we've got to flip the model, because instead of, as data protection vendors, us all chasing after all these different things and coming up with 4 different ways to back up Kafka, vSphere VMs, what have you, maybe we should say, well, you're Kafka. You should understand your data protection needs. You tell us, and you give us the API so we can do the right thing.
But so then how does this work intersect with the quasing, unquasing hooks work that's going on in the data protection working group? I mean, I think it's very similar, right? It's not, it's a similar concept. It's just the protect, the thing that you're trying to define it with, which is the protected entity, is sort of new, but it's not all that different from that thinking.
No, it's not. So I think right now with the quiesce hooks, those are like a primitive that we can put under the snapshot. So a snapshot should quiesce whatever it's snapshotting, capture the storage or whatever it's capturing, pretty much storage, and then in configuration, and then unquiesce. So I could see the quiesce hooks being something that you can use like in your operator. So you're writing an operator that is going to snapshot your whatever you build. You can build this somewhat generically with things like quiesce hook, persistent volume snapshots, and you should be able to build a snapshotter that works without doing a huge amount of work for pass one.
This is Phong from the Dell EMC. I can enhance, I can add a little bit on my experience with Valero on the app consistent aspect that someone just raised the question. So the way we do it is Valero provides us a hook on the pod object, and we can specify a quiesce command in that hook. So when Valero run a backup, for example, if it runs see a pod and it look into the annotation on the hook for the hook, and when we see the annotation pre-hook, it will execute that command that we specify in that. So that's how we can implement the quiesce and unquiesce at the pod level. When the pod being quiesce and unquiesce, we can go ahead and do our snapshot via the vSphere plugin. So that is how we integrate with the Valero for our app consistent backup.
Yeah, I mean, that's actually understood. I mean, what's interesting is the higher level abstraction where, it's not just quiesce, unquiesce, but, create a snapshot, create a backup, or move, whatever it is, and let the app do whatever is needed, under the hood to make it happen, which is interesting. It's just a higher level than just quiesce and unquiesce, because you usually quiesce because you're trying to snap, things like that. Yeah.
I think the motivation for integration but not doing everything at the app level is whether things can be done more efficiently at the storage level. So for example, if you let's say, Kafka to do backup, you may have to copy all the data to a remote site, whereas, you can do it more efficiently if storage is involved and can, only send the dirty deltas to a remote site. So I think that's where like this forum really can help, because it's not just, I mean, there are certain apps that can, take snapshots. Certain apps, quiescing is implicit, some are explicit. Some may back up data locally. We'll just take a local snapshot. Some may back up data to a remote site. So this is, I think, where we're talking about like the building blocks that can benefit a whole range of applications. And I think that's why we're having these discussions, because we can't delegate everything to applications. I mean, we can, but it may not be the most efficient way of doing things.
Well, more like what we want to do is build out abstractions for applications and provide the applications themselves with building blocks. So for example, like say you build out the Kafka snapshot. We want to be able to let the Kafka snapshotter make a decision about how it snapshots its data. And we can provide, for example, like protected entities that are on top of volumes, where Kafka says, okay, the way that I snapshot myself is I call the snapshot API on all of my persistent volumes. Or you might have an application that consists of Kafka and a MongoDB, and you provide your own snapshot API at the top, but what that does is just snapshots Mongo and Kafka, puts the two together plus whatever of your config data you need, and says, okay, that's my snapshot. So the idea here would be to wind up with like a hierarchy, or it's a DAG. It's not a tree, it's a DAG of the components, and have the option at a level like Kafka may say, well, I'm going to be completely opaque. I'm just going to expose out what I do, and anything inside is hidden. Or it may say, yeah, I'm going to show you that I snapshotted a bunch of volumes, and that's part of my snapshot, and let you figure out how to move the data across. That's the goal.
So Dave, do you expect like the operator, like Kafka operator, to do the QoS, or who is going to do QoS in this case?
It would be part of the snapshot. So yes, so the Kafka operator would decide what it needs to do to QoS. So for example, like say we have a volume group, and it can just say, okay, well, here's the volume group. I'm going to snapshot my volume. That's my QoS. That works for me. Or you may have a single volume and say, okay, well, I don't need to QoS. All I need to do is snapshot my single volume. Or it may say, well, you know, inside here, I should run a script. There's some Kafka stuff that happens. There's a QoS hook that I'll call, and that'll have the Kafka app do the right thing. But that should all be, what I want to get is that all hidden behind the API, so that in the DP space, we're not dealing with, you know, long lists of hooks and ordering of hooks and all the rest of that stuff. Because that's kind of like what we're doing right now. Like we'll run across the pods. If we see a pod, we'll execute a execution hook. We don't know what that does. It's just an execution hook. It may do anything. So we don't really know if we're supposed to call a unQoS hook. You know, what's the exit path on this? Those are all things we need that should really be inside the snapshot API, in my opinion.
So if that's the case, it seems to me that then the app operator will be doing everything. Then what does the backup vendor do in that case?
It's called the snapshot API. But so like, for example, like, right now I've taken the Valero Kubernetes serializer and I put it behind the protected entity interface. What we should be able to do is take that serializer and say you're an app, and you say, okay, I'm just defined my app is this namespace. So do a Kubernetes snapshot on however you normally do it on my namespace, and that's my snapshot. So I think there's a partnership between the infrastructure and the app developer and the data protection vendor. So we see a lot of value in the data protection space, scheduling, backup management, security, data movement, data storage. So those are the things that as a backup vendor we'd be handling. But things like, yeah, I do a snapshot of X, we really want to push, I believe we should push that down to the apps.
And what about an application, say a complex application or a polyglot that may use, say, a database, a messaging broker like Kafka, and say, I don't know, some web component. So you are kind of a snapshot on each of these things will be 3 different actions, and you're expecting a higher level entity to understand that, because I've seen there are applications that are Kafka as a service or Postgres as a service, and in those it's pretty easy, or okay, the operator does the thing that you want them to do. But things get quickly kind of they fall apart when you have these polyglot applications where Kafka is there, but that's not the only thing it does. So I guess you still need some level of serialization at a higher level entity which will do these things in some order, because you cannot just say snapshot everything at once. Maybe
no, you can't. Let me we're getting into Astrolabe. How are we doing on time?
7 minutes to go.
Can I share my screen, Nolan?
Yeah.
Oh, I think I need to make you a co-host. Yeah, hold on. Okay, now I'll try to share.
Okay, so this was I've been meaning to put this presentation together for this group. This is actually a presentation I did with Veritas, in 2019. So the idea here would be that we start to look at things as as a DAG, but pretty much you can think of it as a tree, right? So say you have an application that embeds Kafka, that embeds Postgres. Well, the application's protected entity should be able to call into those APIs that Kafka and Postgres are providing upwards. So rather than having the top level flatten everything, we should be able to descend down into this DAG and let these individual levels take care of things. So you may, for example, say, yeah, my Postgres database is Scratch. I don't care if it goes away, so I'm not even going to bother backing it up. I'm not going to snapshot it. It's not going to be part of things, and you hide it from the other pieces. Does that make sense?
Yeah, I mean, this is, I mean, maybe at some point you can give us a little bit of a, you know, a broader presentation on this. So exactly, but if you have to follow this project, Astrolabe is the way to go, right? Go and look it up and see what's going on.
Yeah, and I've been meaning to do this presentation here for a while and just keep getting sidetracked on other things. So we'll do it soon.
I have this is Fong again. I have a small input on that. I think one of the questions was how to serialize when you do backup, how to serialize things to backup one before another. In 1.5.2, Valero 1.5.2, I have introduced a new feature called order resources. So you can specify, for example, if you want to backup 5 ports and you want to backup the first port as like, for example, the application port, and the second port would be like a front end port or something like that. Then you can specify them into that in the backup. So it will execute the backup according to the order that you specify. That is one of the features of Valero 1.5.2.
Yeah, and all the stuff about Astrolabe and protecting entities, like there's an early implementation in the Valero vSphere plugin. I think the longer term goal is to kind of get Valero operating in this worldview. It's not there today, and like Tong said, we have some building blocks, but I think where Valero is at right now is it's very much more aware of the actual process of doing things, and like what we're looking to do in the future is say, well, Valero is more layered, and at the top level it's an orchestrator that receives all these snapshots and then maybe replicates them somewhere, does scheduling, does policy, does permission control, and then having a layer below that that does the protected entity graphs, and then below that is like serialization, snapshotting, that kind of thing. So like the Astrolabe and protected entity stuff is very future looking and kind of where we think we might want to go.
All right. We are at 9:58. Last question, if there's any. If not, thank you so much, Lorna and Dave. It's a very interesting discussion, and learned a lot. Me personally learned a lot, all of it. Everybody in the community is encouraged, if you want to talk about a specific backup product like this, please talk to me and Shin. We will move forward. And with that, thank you all for today's meeting. I'll give you 2 minutes back to your life.
And actually, if anybody's more interested in Valero, please join our community meeting. You can find that from the valero.io page.
Thank you.
Thank you. Bye.
Thank you. Bye.